Okay, today we're putting up some tents. All I have to do, uh, pair each tree with a tent, 1 to 1. So each tree has its own tent next to it. The tents can't touch each other, even diagonally. Okay. And we've got clues telling us how many tents are in each row and column. Well, that makes life easy, doesn't it? I mean, there's obviously a tent here, but which tree does it go to? And I think if we do like that, I think we basically have to get 3 tents on this row. So we can't put a tent here because then they're touching diagonally. In fact, there's no tents in this column. It's 1 in this, 2 in this. So I'm going to do that and that. And that gives me 2 there. And there's 1 here, 2. Oh, wait, there's 2 here. Oh, wait. So if I do 1 here, no, it says there's 0 there. So basically 1 here, that's 2. How do you get a tent? By putting it there because it said there was 1 in this column, of course. Okay, I'm gonna go 10 by 10 now. Notice I'm not doing the hard ones while I'm recording because I don't want to embarrass myself. All right, here we go. There's 4 in this column. Clearly, if we do, I mean, we could do that or we could do that to accommodate all of those. Or we could do, yeah, we could do a whole bunch of things, couldn't we? There's 2 in this, 1 in this. Oh boy. This suddenly got more combinatorial, didn't it? I feel like there is not an obvious a tent has to go here. Wait, there's 0 here. Okay, so if there's not a tent there, then there's probably got to be a tent all the way down here, including this one that accommodates this tree. Okay. So for this one, so this tree needs a tent and that tree needs a tent. I mean, so yeah, so there's got to be 1 here, I think, because we can't put 1 down here or here for these trees. So there's got to be 1 for this tree probably. Now this tree needs a tent. Can the trees? No. The trees cannot I cannot have a tent diagonal to a tree and have it count. So then this tree can't have 1 here, can't have 1 there, so it's got to be there. Okay. Um, this column demands a tent. I'm going to guess there. Or it could be 1 like there. But this tree needs a tent. All right, this row or diagonal line of trees. Hmm. I'm suddenly feeling like this is a much more trial and error kind of puzzle than I realized it was at the beginning. It doesn't have as many where I can use logic and eliminate all but 1 possibility. But here we go. I mean, could there be more than 1 answer even? This only gets 1, and I'm going to put it there. This gets 3, See, I can't do that. I can do that. Oh, this column needs three. Wait, this row can only have two. That gives that row two. This row only has one right now. That eliminates me being able to put any here, though. Oh, but how do I get this tree? Okay, these three are tricky because I can't put one here. But I can put one here, put one there for that one, and then I can put one there for that one. I can put one there for that one, and that accommodates that three. Oh, but this can only have two. Huh. Yeah, I'm feeling like this goes here, and that goes there, and then this goes here. Two, two, two. But that, but I'm really, but now this one is a serious challenge for me. Okay. Oh, there has to be one there. All right, because this is zero. So it has to be one there, it has to be one there. That narrows down a little bit for me. Any other zeros? None here, so there has to be one there. Okay. Two, if this is true, if these are correct, pretty sure that's correct. This one I'm not so sure about. But if that's correct, then there has to be one here. Which really makes this difficult. I think it can only go like that. Oh, but this one, that means this one has to go there. This one has to go there. That one, ah, I might give up on this, even though I feel like I might be close. All right, this has five on this row. One, two, three, four, five. I think these are correct because there's really not anywhere else to put them. This row has zero, but the trees are satisfied. This tree, wait, what is this one doing here? Oh, yeah, because that's for that tree, that's for that tree. Okay, so this tree is satisfied, this tree is satisfied. I'm also inclined to think this column is correct because it kind of has to be. Oh, so that leaves these two trees. I mean, I could do that and that, but it really crowds these trees. But can I do that and that? That also crowds these trees. and it exceeds that. Although this is not a foregone conclusion. Yeah, let's assume that this tree gets one here or one there. I'm not sure where. Oh, let's go there. That satisfies this row or fills this row. This row's filled. This row's filled. That means this tree can only have one either here or here. But there causes problems for me. So that leaves these trees. Well, if that goes there, that goes there, that goes there. Those trees are satisfied. But now I'm over. So maybe this goes here. No. Oh my goodness. What if this goes here? No. Hmm. Okay, that's that tree, that's that tree, that's that tree. How do I do these? We're gonna do one for this, one there, one, and one, whoops, there. But now I'm over three here. And this tree is still not satisfied. Hmm. Wait, I could do one there, right? And I still need to put one here. No, no, I can't do one there. This tree is really, oh wait, if that's for this tree, that's for this tree, that's for that tree. This tree's satisfied. I can do one here, here. No, not there. Okay, putting it here might be too limiting. That might be the only confirmation for these three trees. Which puts this over the top. Okay, wait. All right. So these trees are satisfied. This tree, that tree, these three trees, that tree, that tree. I still have room for one more on this row. This row is satisfied. This row, that row is satisfied. Trees are all set. I feel like I'm almost done. Can I put one here? And that tree is satisfied. And this row is satisfied. This row is satisfied. This row can take two. And that did it. Oh, that one was a tough one.